In the previous video of this playlist, we saw the first problem on Leibnitz theorem. In this problem, let's continue and let's see another question, which will be of great practice to you. And then let's start the video. So second question on Leibniz series would be y is equal to x into e power 2x into sine 3x into cos 2x, and you have to find the nth derivative of y. Okay, yeah, so you have to find the nth derivative of y. So what will you do now? So before that, if you haven't watched the previous video of this playlist, I would highly recommend to you to watch it first, to have a comfortable understanding on this, because this video is a continuation of the previous video. That's why. So how will you find yn, the nth derivative of y? Now, in the previous question, it was very straightforward, right? I mean, this was the previous question, right? X cube into 4 power x. So we said this is u, this is v, because Leibniz theorem says that anything in the form of u into v, two functions multiplied together, u, v, can be applied are eligible to apply the Leibniz theorem. In this case, u was x cube, v was 4 power x. So it was in the form of u into v, so we applied this. So it was straightforward. But in this question, we can see that y is equal to, there is 1, 2, 3, 4 terms in this question. It's not two terms. It's not u and v that is multiplied. It is 1, 2, 3, 4 terms. So how will you solve this? So we have to solve this. I mean, you have to simplify this and bring it to a point where it is in the form of u into v. So how to do that? So we have to use some formula, no other option. So which formula to use? Okay. By the way, I've given all the formulas, trigonometric, logarithmic formulas in the description of this video. Those formulas are more than enough for you to solve any Leibniz question, or I can say those formulas are more than enough for you to simplify any question on which is asked on Leibniz theorem in your mathematics exam, in engineering mathematics. In engineering mathematics, those formulas are more than enough. Okay. So there is no formula that we know such as e power 2x. There's no any formula for e power 2x, right? There is no any formula for x into e power 2x as well. There is no any formula for e power 2x into sine A or sine B, like that. But there is a formula called there is a formula, very popular one, which is sine A into cos B. Look at here. If you consider this as A, this as B, this is nothing but sine A into cos B, right? This part I'm talking about. So that's what I meant. Always when you look at the question, first observe the question and try to locate that portion of the question for which you know the formula. So sine A cos B is a very popular formula, and trust me, in engineering exams, you would only be asked those questions which are quite easy to apply, quite easy to identify, and to quite easy to analyze which formula to apply, like this question. Okay, so it is sine A cos B formula. Let's apply it here. Because for other combinations like e power 2x into sine x and all, we don't know any formula. But we know sine A into cos B. And this is in the form of sine A into cos B. So let's apply it. Sine A into cos B is equal to, okay. By the way, I give many practice questions also. So in the next video will be the last video on Leibniz series. So in the description of the next video, that is the third video of this playlist, I have given many like around 10 to 11 practice questions. So those questions plus these questions plus the questions of the previous video, these are more than enough for you to solve any question. Okay, trust me, these are more than enough. So the formula says that 1 by 2 into sine of a plus b plus sine of a minus b is the sine A cos B formula. So let's apply this here. So y will become e power 2x into, okay, 1 by 2 e power 2x as it is. So from here the formula starts. So 1 by 2 into, okay, 1 by 2 into sine of a plus b, 3x plus 2x is equal to 5x, plus sine of a minus b, 3x minus 2x is x. Okay, we got this. Okay, now yeah, so now since the goal is to find the nth derivative with respect to x, right? I mean, x is the only one variable everywhere in this. So it's obvious that you have to differentiate it with respect to x. So let's take all the x to one side and let's bring all the constants to other side so that we can segregate constants and variables. So 1 by 2 is the only constant here. So I'll take 1 by 2 outside of the bracket and I'll multiply this term inside the bracket. Okay. So you will get it like this. 5x plus x into e power 2x into sine of x. So you will get this. Okay. Now you can apply the direct formula. Which formula to apply? If you watch the if I have all we have already seen nth derivative of standard functions. Okay, the link is given in the description below. Please go check it out. That concept is applicable here. So in that video, we saw it very well that it's these formula that we applied. These 9 formulas that you're seeing, right? These 9 formulas, right? Yeah. So this is, look at here. Now you can apply the Leibnitz theorem. How? If you consider x as u and this entire thing as v, this is nothing in the form of u into v. Okay, u is x, v is this entire portion. And why did I choose this as v? Why not this into this as v? Or I mean, why did I choose e power 2x into sine of 5x as v? Because for this we already know a formula, which is this. See, y is equal to e power x sine of bx plus c. Okay, so there is a direct formula. Because of this knowledge that we have, that there is a direct formula, we chose v as this entire term, or else we would have chosen as something else. But since we know there is a direct formula for this part, we choose v as this so that it becomes easy to find the nth derivative of v, because the Leibniz theorem demands the nth derivative. I'll write the formula for Leibniz theorem, don't worry. So if I consider this as u and this as v, and same thing here, this x as u and this as v, now it's sorted, right? There is a plus in between, which means these two terms can be individually solved using Leibniz theorem. So you can consider this as f if you want, something like f, and this term you can consider it as something like q. Okay, so the goal is to find yn. Yn would be 1 by 2 into fn plus qn. Okay, yn is, y is this, so nth derivative of y would be nth derivative of this term, which is f, plus nth derivative of this term, because individually I'm going to apply the Leibniz theorem, because there is plus in between. Wherever there is plus or minus in between, you can solve it individually, the differentiation, by applying any formula. In this case, it's a Leibniz formula. Okay, so yn would be, differentiation of this would be fn plus nth derivative, differentiation of this would be qn. Okay, so this is what we have to solve actually. We know we have considered this entire thing as f and this as q. Okay, so let's individually solve it. So let's solve this portion first. Let's take f as e into e power 2x into sine of 5x. Now let's find the nth derivative of this, and then let's try to find the nth derivative of q. After that, just whatever result of this, put it here. Whatever the result of qn, put it here, and that will be a final yn. Okay, yes. So how to find the nth derivative of this? Again, I'm telling you, you let u be equal to x, and then let v be equal to e power 2x into sine of 5x. Why did I choose v as this? Because this formula we already know. There is a direct formula, right? There is a direct formula. So that's why I chose u as x and v as this, so that it becomes easy to solve the nth derivative. Suppose if we wouldn't have known the nth derivative of this, so that means you have to again apply some formula and simplify it further, or you go for some other combinations, like maybe this would have been u and this would have been v, something like that. But in this case, we clearly know that there is a direct formula for this portion. So I took v as this. Now let me write the Leibniz formula. So Leibniz formula says that if you find anything in the form of u into v, where u and v are functions, in this case x is u, this the rest of the term is v. So Leibniz theorem is given by uvn plus nc1 u1 vn minus 1 plus nc2 u2 vn minus 1 plus nc3 u3 n minus 3 plus nc4 u4 vn minus 4 It goes on and on and on. There are many terms. Okay, we don't know how many terms. I'll tell you how many terms are there in for this solution, how to find and all that. It goes on and on until this is the last term. So this is the Leibniz formula. Okay, look at here. Vn, which means nth derivative of v. What is v? This one. I think now you understood why I took v as this, because since you already know there is a direct formula for nth derivative for this portion, and since we need that in everywhere, look at here, everywhere we need vn minus 1, vn minus 2. That's why that's a conviction. We have to have that conviction while solving. We have to like wisely select which should be u and which should be v. In this case, since we know the direct formula for this, we selected that as v, because we need it everywhere in the Leibniz formula. Yeah, I think now it's crystal clear. Now, okay, now let's find u1 first, u2 next. Let's find all the u's first, and then let's find all the v's next, and then let's find nc1, nc2, nc3, all the ncrs, put all the values, and then finally find fn, the nth derivative of f. Okay, so let's start with u1. Okay, what is u? X. u1 means nothing but the first order derivative of u. So what is the differentiation of x? 1, right? That is general. If you're wondering how, just apply this formula. Differentiation of x to the power n with respect to x is n into x to the power n minus 1. For those people who have no idea about these basic differentiation formulas, in the description of this video, I have given all the basic formulas of differentiation. Those are more than enough. Just by heart it or memorize it and apply directly wherever you solve. Okay, that shouldn't be a problem. So, okay, so what is this? X, right? Okay, can I write x as x power 1? Yes, I can write. And what is this? Differentiation of x power n is equal to n into x to the power n minus 1. So the differentiation of this, differentiation of this would be n into x to the power n minus 1. What is n here? 1. 1 into n minus 1. N is 1. So 1 minus 1. So 1 into x to the power 0. Am I right? And anything to the power 0 is 1. So this is nothing but 1 into 1. 1 into 1 is 1. So that's how we got that's how I got a differentiation of u is 1. Okay. This is just for your understanding. Okay. For those people who already know this, just ignore it. That's it. So the first differentiation of u is 1. And then next what? Next is, we also need u1, u2, u3, u4, so on, right? So let's, we got u1. So let's go for u2 now. u2 is what? Differentiation of u1 is u2. Differentiation of u2 will be u3. Differentiation of u3 will be u4. It's like that. So differentiation of 1 is a constant. So differentiation of any constant is 0. Okay. This is u2. What is u3? Differentiation of u2. u2 is 0. 0 is again a constant. So differentiation of 0 would be 0. And u4 is what? u4 is differentiation of u3. u3 is what? 0. Differentiation of any constant again is 0. So every term from now, u4, u5, u6, u7, u8, u countless, u1000, u10,000, everything will have 0 from here. Okay, everything is going to be 0 from here. So this proves that for this f, right, the solution is going to have only 2 terms, which is this, and from here it's not going to have. Only the first 2 terms it's going to have. How? Why? Because u2 is 0. Where is u2? Look at here. If you put 0, the entire term becomes 0, because it's a multiplication here, right? Anything into 0 is 0. So if u2 becomes 0, this entire expression is automatically going to be 0. And u3 is what? Again 0. So this will be 0. u4 is what? Again 0. This will be 0. u5, u6, everything is going to be 0. So everything from this term is going to be 0. So that's why for this particular question, for this particular function, only first 2 terms will be present in the solution. So this is how you learn how to find the number of terms that are going to be present in the final solution. Okay. Now, very important point. There can be cases where none of the u's are 0. In that case, what will you do? Here at some point u was 0, so we got to know that only 2 terms will exist, this term and this term. From this term it will not exist because u2 is present from this term. There can be questions for which none of the u's are 0. Yes, there can be such cases. How will you tackle those cases? Don't worry. In the next question, in the next video of this playlist, we are going to see one such question where none of the u's are going to be 0. And in that video, I'll teach you how to handle that case. So in this case, it's 0. So it'll have only first two terms. Okay. So subscribe the channel to stay close to my content. Okay. Next, u is over. Okay. And then one tip I would say is always begin with finding the u's first. And then let's go for v. And then let's go for this. Why begin with u? Because it's only u that will tell you how many terms are going to be present. Like here. See, I started with finding u. u2 was 0. By this, I got to know that only first two terms are going to be present. So all I need for now is vn, nc1 and vn minus 1. No need to find v of n minus 2, vn minus 3 because I told you from this term it's not going to be present. So this will save a lot of time in the examination while solving such questions. Also, always go for u first. Find all the u's. By finding all the u's, you will know how many terms are going to be present in the solution. So by this, a lot of time will get saved for you. Yes, again, coming to the point, there can be cases where none of the u's are 0. I'll teach you how to handle that case in the next video. Okay. Now, u's are over. Let's find vn because vn is also a requirement here. So v is what? First, we'll write v clearly here. V is okay. This is v. Now vn is what? Which formula to apply here? Can I say this is again? I told you, right? Yeah, I already told you this. This is in the form of, we already have a direct formula. So e power ax into, so let's apply that formula here. So if y is equal to e power ax into sine of bx plus c, that implies that nth derivative would be root over a square plus b square power n e power ax sine of n into tan inverse of b minus a plus bx plus c. Okay, this is a big formula. There was no space here. I'm so sorry for that, but it's okay. See, in place of a, we have 2. Okay, so we have a as 2. In place of b, we have 5. So b is 5. In place of c, there is nothing. There's only 5x here. So to give some value to c, I'm just going to put plus 0. 5x plus 0 is 5x only. So you can change 5x as 5x plus 0. I'm just trying to make it something. I'm just trying to make it equivalent to this particular form so that it gets the eligibility to apply this formula. So there is nothing in C. So I just put plus is equal to 0. So in place of C now we have 0. This is just to make this in this form so that you can apply it comfortably. So C would be 0. We have A, we have B, we have C. Put A, B, C in this formula and find the nth derivative of V, find Vn. So I'm just going to quickly substitute here and directly write Vn. So Vn would be root over 4 plus 25 to the power n e power 2x sine of n into tan inverse. Let me write it directly, okay? So root over 29 into n into e power 2x sine of n into tan inverse of 5 by 2 plus 5x. Okay, this is the Vn. Okay, if you're wondering how did I get such a big expression, pause the video, or after the video you can just put in all these values. Put ABC here and just substitute in here and you will get this. That's it. That's all. As simple as that. You will get this. Okay. So Vn is done, and our requirement is Vn minus 1 as well. Okay, Vn minus 1 as well. Vn minus 2 not required because I told you this particular question is going to have only these two terms. From this term, it's not going to be there. So don't need to find all this. Let's find Vn minus 1 and nc1 and we are done. So quickly let's find Vn minus 1. That would be root of 29 to the power n. How to find, by the way, once you find Vn, right? How to find Vn minus 1? Wherever you see n Wherever you see n, in the nth place, put n minus 1. If I find a v n minus 2, wherever you see n, just in place of that n, put n minus 2. Here it is n minus 1. So wherever I see n, I'm just substituting n with n minus 1. Okay. It's as simple as that. Sine of n minus 1 into tan inverse of 5 by 2 plus 5x. That's all is n minus 1. Now, next requirement, last requirement is NC1. Okay, NC1 is the last requirement. So NC1 is equal to, the formula of NCR is equal to n factorial by n minus r factorial into r factorial, right? This is the formula. In place of r, we have 1. So n factorial by n minus 1 factorial into r factorial, which is 1 factorial. I can write n factorial as n into n minus 1 factorial by n minus 1 factorial. 1 factorial is 1 itself. So n minus 1 factorial and n minus 1 factorial will cancel, and then n by 1 will be remaining, which is n. So NC1 is, we found it as n. Okay. If you're wondering how I got, I mean, how did I do this part? Please watch my previous video. Detailedly, I have explained how to write, how to solve this kind of NCR problem to get a simplified solution. So please watch the previous video. That's it. So NC1 is also done. Now everything we have everything. Okay. Since we have everything now, let's finally find Fn. Okay. Now our goal is to find the Fn. F is this. Okay. Now since we have all the data of Leibniz theorem, let's put in all the values NC1, U1, Vn, whatever we found here, and then finally let's find Fn, the nth derivative of f. So after substituting all the values, I'm directly writing the solution. The thing here. So you will get this as your Fn. Sine of n into tan inverse of 5 by 2 plus 5x plus n into 1 into root 29 to the power n minus 1 into 2x sine of n minus 1 into tan inverse of 5 by 2 plus 5x. After you, I directly wrote it. Okay, don't get confused. I'm so sorry. Yeah. So Fn would be this. Okay. After substituting all the values that we found in that Leibniz theorem, you'll finally get this as your Fn. Okay. Now the sum is not over, because we have to also find Qn. See here, Yn would be 1 by 2, 1 by 2, 1 by 2, the same 1 by 2 here, into Fn plus Qn. Fn we have found now. Qn also we have to find. So that I'm giving you as a assignment, because that would take too long. Okay. But I will solve it partially. The second half you can do it. And then the final answer, I'll write it here. Don't worry. Okay. So Q is nothing but this, right? Yeah. So Q is nothing but this. So considering U as this and V as e power, sine of x, right? Sine of x. Now, if you ask me why did I take V as this, why not V as something else? Okay. Same reason. We already have a direct formula, which is this one, right? This one. We already have a direct formula, which is this. Okay. So that's why here also in the Q, in this case also, the reason is same. I have a direct formula for e power ax into sine of ax plus bx plus c. So that's why I'm choosing V as this, so that it will be easy for me to calculate Vn minus 1, Vn minus 2, which the Leibniz theorem demands from us. Okay. So yeah. So Leibniz theorem, apply Leibniz theorem here also. U into V, it's in the form of U into V. So Leibniz theorem, apply it here. So U1 would be what? 1. X is 1. U2 would be what? 0. U3 would be what? 0. Same story here also. From U2, everything is going to be 0 again. And because of that, this solution is also going to have only the first two terms, which is this and this. Yes. Luckily, Not, yeah, luckily, why I said luckily, because it's only two terms and your and our calculation will be much more easier. That's why I said luckily. So u2, u3, everything is going to be 0. So this is going to have only two terms. Let me write it here. Only two terms. Okay. Yeah. And then find Vn as usual. Find Vn and then find Vn minus 1. Okay. And then we already know NC1 is n. So there is nothing to find there. Once you have all these values, I mean, u1 is already there. You have to just find Vn and Vn minus 1. Okay. I've already taught you in the previous in the previous case, right? So same thing here. Once you get all this, put it in the Leibniz theorem, and then you will finally get Qn as one entire expression. So find it. Okay. So let me write it. I'm not writing it here. I'll finally write it in the final answer. Okay. I don't write it again and here and again there. So you'll get Qn. Okay. So after you get Qn, that's all. Yn is equal to 1 by 2 into Fn plus Qn. Fn we already got it. Qn you will get it by that method, but in the same way. So finally, Yn would be something like this. I will write it directly. Okay, just cross check it with your answer. So 1 by 2 into Fn plus Qn, right? Yeah. So 1 by 2 into Fn, we already solved it here. We already solved it. So let me write it same thing, copy paste. I am just copy pasting. Okay, so don't get any confusion here, not required. So root 29 power n e power 2x sine into tan inverse of 5 by 2 plus 5x, okay, plus n into 1 into root 29 to the power n minus 1 into 2x into sine of n minus 1 tan inverse of 5 by 2 plus 5x. Nothing, I'm just copy pasting that same Fn here to show you the final answer. Okay, Fn is done and plus is there, right? That's plus, you take it as it is. And then Qn, that is your assignment. Okay, what I mean, you will get it off. It's very easy. All you need to just find Vn minus 1, put it in the Leibniz formula and get Qn. So your final Qn, I will write it here, Qn. Find Qn and then you can cross check it with this part. Qn, now I'll write Qn. Qn would be something like this. Okay. Again, do the assignment and then just verify it with this, whether you have got it correct or not. So this will be your Qn. So this is your final yn, the nth derivative of y. Okay, what is y? This one. It's that simple. So please don't end it here. Watch the next video of this playlist. I have that question will give you again a better understanding, because that question is tackling a new fresh test case, a fresh case that Leibniz theorem is typically it has in its questions. So don't think that you know everything now, because the next question is going to be very crucial. You trust me. The before video, the part 1 video, this video, and the part 3 video, this is the next video. These 3 videos along with the practice questions that I am going to give in the next video, if you do all this, any question from Leibniz theorem, you will be able to crack it. And then in the description of this video, I've given all the formulas, basic differentiation formulas, trigonometric formulas, logarithmic formulas, very simple ones. Just memorize them and you're done. Any question you'll get out also in your exams if you do all this. So that's it with this video. And then I also teach, I'm also a software engineer, and I also teach these frameworks that you're seeing on the screen right now, front end, back end, full stack, and all these languages that you're seeing right now on the screen. So if you're interested to learn this from me personally, in the description of this video, I've given an email ID. Email your interest or whatever you want to inquire regarding the training, and I will immediately reply to it, and let's start immediately. Okay. So so that's it. So make sure you watch the before video of this. The link is in the description. So I'll see you in the next video. of this playlist. That will be the last video, and after that we'll be done. Thank you.